Good morning, good afternoon all here. Today we're gonna run software development life cycle. This is the YouTube channel where you'll explore more things about software development. So I will just encourage you to just search or look after this Amazon web service where you will search more about software development life cycle. So I want you to follow and understand deeply more about SDLC, which is software development life cycle. So then what is software development life cycle? Why is it important in daily life? How does it work? So then what are the models? Uh, how does SDLC address security and others? So first in this session, we're gonna look about these four first questions. Then after we'll just look another in the following video. Welcome this YouTube channel. Welcome once again. This is YouTube channel where you will explore more about software development life cycle. So then, uh, software development life cycle is cost-effective and time-effective process that development teams use and build high quality software. This software development life cycle just describes the way through which a developer must so that his or her software will become at the market, fulfilling all the standards. So if you want to become a best developer, you must follow these these life cycle so that your project will have all things brainstormed at the big. So whenever you're gonna start software development, you start by thinking about or brainstorm the idea. So why am I gonna take this idea into codes, into how we're gonna develop this solution? Why am I taking this solution? So as you see here, the software development life cycle is the cost-effective and time-efficient develop teams use to design, build high-quality software. You see, I think you're understanding deeply that software development life cycle just enforces that in order to build high-quality software, you must follow the SDLC, which is software development life cycle. This goal or targets on minimizing the project risks. Most developers take uh, take into practice just implementing the solution, but without thinking deeply or brainstorming about the idea. What are you trying to solve? What are you trying to have on your website, on your mobile application, or other things that you're gonna develop? So then, uh, this methodology outlines a series of steps that divide the software development process into tasks you can assign, complete, and measure. So, whenever you're developing something, you have steps. Uh, First, you brainstorm the idea. After brainstorming the idea, you about, to brainstorm or to think about the idea, you firstly get the query within the society. So, after getting such problem, you come up with uh, the solution. That solution you're gonna brainstorm. Then you get how to solve this query. How can I do this? How can I relaunch this so that the users may be intuitive, interact well with the system. So why is the SDL so important? You know, I was saying that for you to build the high quality software, you must follow this SDLC life cycle, software development life cycle. So why? Let's look together the reason why is important to take it into account. Software development can be challenging to manage due to changing requirements, technology upgrades, and cross-functional collaboration. This means that whenever you're developing a software, You may be challenged with those who are helping you to get into the point. You see, you may be changing the requirements, like you know, uh, you may have a PC uh, which is zero, like having an SSD which is zero or RAM which is zero. So as you change and as you change the device you are using, may cause you to be interrupted, to be bored. So technology progress. You may be programming using a more one programming language, then you modify or you upgrade, you go to another step. So to change those things may be very challenging. Then and cross-functional collaboration. Uh, when you are dealing with a team project, sometimes you need collaboration between your team. So when one of the team works as they disagree with these things, so it can be challenging. The self-development cycle methodology provides semantic management framework with a specific deliverable at every stage of the software development process. So as a result, all stakeholders agree on software development goals and requirements up front. Also, have a plan to achieve those goals. Because if you have a life cycle, the process through which a given software must be obtained from those. If it passes through such way, such life cycle, just means to have high quality. You know, are you getting? Good. May I ask some question? Wow. Why do we need software development life cycle? Wow, I think you are getting. Just whenever I'm building a software, I'm developing a software, I need to get the high quality product, high quality software after the job. Good. So then we look after the benefit of software development life cycle. Software development life cycle, you're gonna see more advantages, more benefits from it. The first thing, to increase visibility of the development process for all stakeholders involved. These things mean that this software development life cycle, it's an international life cycle at all. Whenever you present, you deploy, you show others what you have done in your job, they will just treat them. Does this software pass through SDLC? If it passed through it, so the project development will be visible, will be internationally recognized. The second, efficient estimation, planning, and scheduling. You know, when you're gonna take a task like learning new things, developing something new, you're gonna set a time of compression. So that's why here there is estimation. You first estimate, uh, will I do this in how many minutes or time? Then what's my plan? What I'm scheduling now. So after that, you're gonna improve risk management, cost estimation. If this process, if you have a software, then you're gonna develop it step by step. You may take off some of the risk management. When I'm starting a project, define. If I start by defining, I see that the idea is impossible. You relate it without implementing or losing more money, much money. So the fourth one is systematic software delivery and the better customer satisfaction. When I'm building, following the legal or the standard of developing software, there is no need to bore my customer to be confused or conflicting between me and my customer. So then they will go another step of how SDLs work. How does it work? How? Oh, good, good, good. SDLs just have uh, some of the categories of how it works. The first one is to plan. Plan, we design, we implement, we test, deploy, and lastly maintain. We pass through it deeply so that you understand. I'm gonna to dive into so that you understand. Um, Thank you to follow fast, then you will know more things. So SDLs have fewer things to deal. First, you plan. You know, whatever you're gonna do in software development, you plan. You firstly know why I'm going to do this. Define the problem. Know the reason behind your solution you're gonna deliver into the society. That's the first things. So after thinking about, you propose the solution. Does this solution solve this? So in planning, you see what question the society want to solve, what's the proposed solution, what is the alternative. After thinking deeper about the query, thinking about the question, then you have proposed the solutions, you have tested them, you see that they are possible, then you design. You implement what you think into designing. You set the design, how design will it look, how we analyze the requirements and identify the best solution to create the software. What requirement will I need? How can I create the best software following the standard for the SDLC? So then after we implement. This is the implementation phase where your team may write code for my software needs some codes. Then after implementing my code, I will just test. I test if my code works well. Is this UI UX user interface experience shows to the client well? Does it works well? Does it have some test may be done here so to check is there any error? If there's any error, must be uh, set to be debugged so that the codes may work as expected. Sometimes many teams immediately test the code they write, and the testing phase often run prior to the development phase. So, as to develop without having more errors, I recommend you to test. As you write the code, test. As you write the code, test. As you write the code, test. So that's why I'm saying that the run is parallel. You develop and test, develop and test, so that whenever I have, think of if you have 20 billion of, how may you test it uh, at the whole back as the whole package? But if you test 100 line or 10 or how you break into small pieces so the testing may be easy. The second one is that deploy. After testing that your software fulfill the standard, uh, test. After testing, after looking that your software interact well, do what it's expected to do, then you may deploy it. For instance, if you have web app, mobile application, and others, just you deploy. You deploy. What does it mean to deploy? Just you take the project, the resource from one to another. That's it, why the term deploying means. So then the last is to maintain. After deploying your software, you have to maintain it so that it will never have any runtime errors in the future. In the maintenance phase, among other tasks, the team fixed bugs and resolve customer issues. Whenever you deploy a software, users will need to utilize it. So in using such a software may meet with some error debugs, so that some of the developers will have the task that they have to go and fix the issues, fix the bugs, resolve the customer issues. If they request you that we need the charts within this software, so you go integrate it. So you're just maintaining the software. If attackers needed to hack the software, you go there and make some change, something to do. So when you reach there, you do something which is very, very recommendative and possible to protect your software and your customer. Thank you. Awesome. We are about to end this. Uh, I think they will look on this last chapter, what are SDLC models. SDLC model, we have waterfall model. This waterfall model arranges the phase sequentially so that each new phase depends on the outcome of the previous phase. Conceptually, the design flows from one phase down to the next, like that. When the water is falling through a pipe, means there is, if we have part one and part two. So the part one is the first one. In order for water to Part 2 must first pass through part 1. So that's why in waterfall model, the first phase gives or provides the access to for the second phase. If first phase fail, second phase can't work. So then what's do you look after? If I say waterfall, this model provides sprint to project management, gives a tangible output at the end of each phase. When you have a phase, for instance, for developing a form, then your form is functioning, it's doing well, then you may follow with something which is the following phase. So if one phase fail in waterfall, the second phase can't work. So that's why it's very productive and to be used well in development. So the second is iterative. Iterative. The iterative approach suggests that teams begin software development with small subset of requirement, then the iteratively enhanced version over time until the complete software is ready for production. The team produces new software version at the end of each iteration. As the term means iterative, just to repeat something, do one it twice, thrice, and so on. So these things mean that the software, the team may use the requirements is available. You may see that you need a HP laptop or Macintosh laptop, then you have a PC, you have a Lenovo. So you may develop using such a laptop. Then after you integrate, you never have another laptop, which is the requirement you need. That's to say, for iterative, you write one software, but in another second by using a version. First a version developed using the second using this. As the requirements differs, you have to create some. You have to create so the software by using updating. So it is easy to identify and manage risks. For iterative, we have some which is the positive benefit, the benefit of using iterative models. It is to identify and manage risk as the requirement can change between iteration. As I'm saying, in an iteration, we use requirements which is different. I may start by using this Lenovo laptop, then after I use another things which is when the requirement changes, I may have version 1 with a given requirement and the version 2 for the other requirements. So CPRO, that is the third CPRO model, combine the iterative model, small repeated cycle with the waterfall. This combines both waterfall. We have seen that it follows like a phase. If phase 1 fail, phase 2 also can't work. So for iterative, we have to use a subset of requirements. If we have requirements 1, we develop a software for that. Then if we have an upgrade, we have big or more resources, we develop a version 2. As the requirements 1 produces version 1 and the requirements 2 produces version 2. So then for CPRO, we combine those. We combine the waterfall and iterative models. So this why is it that this is important? Because it helps you to prioritize the analysis. You take something through waterfall and others through iterative. So then the CPRO model is suitable for large and complex projects that require frequent changes. If you have big project, a complex project, you need CPRO models. CIST combines waterfall and iterative one. Waterfall, as we have seen, it's just to look after. Does the first the first phase works well? If the test is okay, you follow the second phase. Then for iterative, if we have a version 1, we need a version to do to the requirements we have. In the first version, I'm having given requirements. The version 2, we have the second requirements. So that's why if you have complex projects, large and complex, which may approach to use the CPRO model. So then agile models. Agile model arranges this phase into several development cycles. The team iterates through the phases rapidly, delivering on small incremental software changes each cycle. This agile breaks down into several phases where the team learn look at small portion, small, but looking the incremental are being done within this software in each cycle. They continuously evaluate requirement, plans, and results so that they can respond quickly to the changes. For Agile, sometimes it's done by larger group. If they take something, break down into small pieces, then they go check this, check this, check this, check this. So as they check, I mean, they will just to minimize the risk within the project. They continuously evaluate the requirements and plans and the results so that they can respond quickly to the change. Whenever a given a change occurs within a given piece, they have to recommend or do this to recommend you how to resolve it. So this mm, rapid development cycles help team identify and address issues in a complex project early on and before they become significant problem. When you break down your problem, you have a problem, then you break it down into smaller pieces. You're gonna have something which is easy, and then you will also have the probability of avoiding any issues which may arise due to the complexity of your project. If you have a query if your project, then you break down it into pieces. You're gonna write this part, tomorrow you do this, then next you do this. So such a things will makes you to see and to have your software updated and well deployed. That was the last models SDLC models where you may follow is as I pass through it. So as to end our session, we will start with waterfall. Ah, to make summary of what we have looked today, just want to feel free pass through your these models only so that we may end the session. Let's do this models. First, start with the waterfall. That's the first model. This waterfall, you have seen that it uses phases. If I have the phase one, the phase two, then the phase one, it's the first, the second is the second. Then if phase one failed, phase number two can't work. The second, that's iterative models. For iterative models, you may use the subset of requirements. You may have requirements one and requirement two. Assuming that requirement one, you have something to use at the start path at the start one start. Then after you may have another requirement. So for the first requirement, we may create a software with let me call version one. Then with the second requirement, you may have uh, you may have another software which is called version. It means you take the version one, you update it, you upgrade. So such a things to upgrade and update means you are using iterative. So after iterative, we go with Spiro models. Spiro models just combine waterfall and iterative one. This is better also to recommend you whenever you have large and complex project to deal with CPRO. To use a CPRO model is to combine the waterfall. We may test the phase per phase to phase. So to ensure your accuracy. Also, iterative for you to just pass through your codes always looking that there must be a change to do, there must be to change something. So as you pass through the codes, through the phase, through the pieces, you see what to improve. So the last agile, where agile breaks down into several phases, you take the circle, then you break it down into several phases. So as you develop, you cut down into pieces. This may also help you to develop complex. Whenever I have something which is very complex, when you break it down into pieces to handle such a query, such a question, will it be more easy than to handle it deep as back. But to use it whenever you're gonna develop complex projects, I recommend you to follow the agile model. Thank you for this. Thank you for watching for this channel. I would like to recommend you to subscribe and also to share comments. It's very helpful to get things ready and also help you to learn something which is new. Have a wonderful evening. Thank you.